start recording that. And yeah, let me pull up my Jamboard here. And so we're going to take the quiz at the end of the class period. So that's coming up here. So I don't know, 2 people left. Hopefully they take the quiz because that's 10 points, test points that they're going to be missing. All right. So yeah, we need to be Zooming during that quiz too. If you're not Zooming, it's not valid. Okay. Oops. I didn't mean to do that. I meant to go back a slide. All right. So need to go to the beginning here. So I've cut out certain problems from the worksheet. All right. So here's like the first 8 problems. Rewrite the quadratic function in the form f of x equals a times x minus h squared plus k. Then sketch the graph. So these are all quadratics, right? Which are all parabolas. And there's one I'm going to do with you today. Right now is going to be number 6 so that I can, people keep sending me chats. All right. Okay, thanks. Number 6. So we're going to start with number 6. Let me get my pen up here. Change from red to blue. All right. So I'm doing number 6 here. And just review of completing the square. This will help you with your quiz today. Y equals, instead of f of x, I'm going to use y equals 2x squared plus 16x plus 33. Right? It says change it to this form, which requires us to complete the square. Right now it's in standard form. We want to get into graphing form or vertex form. So 33 is not a perfect square, so we're going to move the 33 to the other side. I'm going to subtract 33 here, subtract 33 here, and we're going to get y minus 33 equals 2x squared plus 16x. Okay, and I want to start completing the square here, but another chat. Okay, and Sierra, if you could put what name you're under, that would be great, because I'm not looking at that right now. Okay, so you can't have a number in front of the x squared, so we need to get rid of that number in front of the x squared. So to get rid of it, we factor it out, right? I'm going to take out a 2, which means I'm going to take out a factor of 2 from the 16 too, right? So 2 times x squared plus 8x plus some number that we're going to use to complete the square. Why do you guys keep sending me messages in the chat? Okay, thank you. All right. Y minus 33. All right, so to complete the square, 8 is on the bottom here, and half of 8 is 4, and 4, we split it in half. 4 times 4 is 16. So the perfect square that would complete the square is 16. So normally I would add 16 over here, but I'm adding more than 16 because we have that 2 out in front. So we want to multiply that 2 times 16. That's 32. So we need to add 32 to the left, and we're adding 32 to the right by putting that 2 times 16 there. Okay, so this negative 33 plus 32, that's negative 1. So y minus 1 equals 2 times. Now I can change this, x squared plus 8x plus 16, that's just x plus 4 squared, right? So now we're looking like our vertex form because we've got a square, a perfect square in there. The standard form doesn't have a square. So that's why we added that 16 there to make it a perfect square. Our last step is to add the 1 back to the other side, and that will give us our equation, which is y equals 2 times x plus 4 squared plus 1. That's in vertex form. And please box your answers when you're done. What is our h and our k? This is the opposite of h. This is k. So negative 4, 1 is the vertex, right? And it says to sketch the graph of these. And so whenever you do a graph, you should have some kind of work. Notice there was a lot of work with this, right? Like you can't just come up with a graph out of thin air unless you use Desmos or something like that. So if you give me a graph on a quiz or a test with no work, then you're not going to get any credit, okay? You have to show work. So 1, 2, 3.
Wait, I have a
4.
question.
Excuse me?
Why didn't you, when it was y minus 1, why didn't you like previously just add 33 instead of 32?
Hold on one second. Okay, so if we need to graph this, so our vertex is at -4, 1, and my A value is 2. So that means I'm going to go over 1, up 2 to like 3 here. And same thing here, over 1 to -5 and up 2. And then I go over 1, up 6, which would bring me to like 9, right? 9. And then over 1, up 6, which would bring me to -6, +9. And that would give me my stretch of 2, vertical stretch of 2. Okay, so I didn't come up with the graph out of thin air. There was a lot of work there for the graph. Okay, so on all these problems, there needs to be work. So you're going to be submitting several pages of work. So please scan the work in and don't just send me 3 or 4 pictures, separate pictures that I have to click through because it takes a long time to load in Google Classroom. Please scan them all in. All right, so that is number 6. The next one I was going to move on to, I have to clear this out, is number, I think 10. Yeah, is it 10 I'm doing? Oh, 9. I'm going to do 9 and 12 if possible. So number 9, put a background on here. There we go. Write the exact equation of the function of the form. So I want to write it in vertex form again that passes through these given points. So your vertex is 2, -6 and passing through the point 3, -7. So let me I need to get my pen back. There we go. Okay, so number 9, so I have the vertex is at 2, -6. So that's my H, my K, right? And then one of the points is 3, -7. So that's my X and my Y. And if I want, I could do a sketch of this, which is actually kind of a good idea. So vertex is at 2, -6. 2, -6, 3, -7. So if I did a little sketch over here, 2, -6, let's just say, okay, 2, 4, 6. I'm going to actually use the graph paper on my paper. 2, -6 is here. 3, -7 is right next to it. So it says, hey, is this graph going up or down? Well, if this is the vertex at 2, -6, which we always, and that's a point on the graph, then it's obviously going down, right? And I would mirror this point over here. So this graph is going down, down. Okay, and we can find that out through the equation. So this is something that you're going to have to do on the test is plug in points to this equation. Okay, so our equation is y equals a times x minus h squared plus k, which is something you can find on your parent toolkit. You're going to be allowed to use your parent toolkit on the test, but not anything else. Okay, so and a scientific calculator, but that's it. No graphing calculators, stuff like that. I gotta get my pen back. Okay, so we have h, k, x, and y, and if you look at your equation, you can plug in h, k, x, and y, and what you'll be able to solve for is a. Okay, and that's what you're gonna have to do lots of times. Whenever they give you a point and a vertex point, you're gonna be solving for a. That's our goal. And then once we find a, we can plug it back in and plug in a, h, and k, and have an equation for our parabola. All right, so my y value, start with the y value is -7, so I'm going to plug in -7 equals a, I don't know. X, my x value is 3 minus my h value, which is 2 squared, and then my k value is -6. Okay, so I plugged in x, y, h, and k in the correct order. Now we simplify order of operations. You're going to do parentheses first. 3 minus 1, 3 minus 2 is 1 squared times a minus 6 equals -7. Okay, so we multiply this because multiplication comes before subtraction. You do not subtract first. So this gives me 1a, or just a minus 6 equals -7. That is the order of operations for that. Then we add 6 to both sides. -7 plus 6 is -1 equals a. Oh, a turned out to be negative. That means my parabola should be going down. Yay. So now we just have to plug in what a is and what h and k are into our equation to get our equation. So my equation is going to be, instead of y, I'm going to use f of x because it was given to me as f of x up here. It doesn't matter which one you use, but you know, I'll just stay consistent. My a value is -1, so negative x, and then my h value is 2 minus 2 squared. Don't forget to put a squared for a parabola. My k value is -6. So that is the equation of the parabola that passes through the points 2, -6 and 3, -7, because we plugged in the points into the equation to get that a value. Okay, and you're definitely going to have to do something like that on the test. So that's number 9.
Ms. Wakefield?
Yes.
Because the vertex is technically a point, if you're only given the vertex, could you plug it in?
Okay, so that is number 9. The next problem I'm going to do with you, I wanted to look at 12. I'm going to skip it. 12 is the same. It's just negatives. The reason why I was going to do number 12 is like I just wanted to have a negative h and k. So when here's my h, here's my k. So your h is going to be negative. So when you plug it in, make sure you do x, you know, minus -8 squared, which would turn it into a positive. So just be careful with your negatives. You know, since it's a minus, it's going to turn that negative into a positive. That's the main thing I wanted to cover with number 12. But we have a lot to cover today. So I'm going to move on to the next one, which is, clear this drawing out, which is one of 13 through 16 here, which 16. I'm going to do 16 here. Identify the domain and range of each, then sketch the graph. Okay, so let me bring my pen back here. 16, you can copy down that equation. And let me write it down. Y equals -√of x. So this is a radical equation, right? In my mind, I know it looks something, it looks like this, right? But actually, since it's got a negative in front, it's going to flip upside down. It's going to look like that. So it has a maximum point, right? That point is a maximum. And later on, it's going to ask us for that later on in the homework. But that maximum is your vertex. That's your h, your k, right? And it's easy to find that point because, you know, this is our a. It's y equals a times x minus h, or parentheses, or plus k. Okay, so my h is the opposite of this. You know, my hk is opposite of +4, -4. And my k is 4, +4, right? We always take the opposite underneath the parentheses, or in this case, the square root. Take the opposite of that number. So -4. So that point right there is -4, 4, right? That's my maximum. And it's flipped upside down because of the negative. So we make a little sketch, and that's your, so this is going to determine your domain and range. So there's your sketch. You know, I should, -4, 4 is, I should draw that. -4, +4 is like here. -4, +4 is up here. So my graph is going to go, and it's -1. So I think it goes down 1 over 1, down 1 over 4, I believe, pretty sure, and then down 1 over 9. Okay, so that's -4, 4. So now we can do domain and range pretty easily because we have a graph. Okay, your domain is from here to the right, right? So it's at -4, and you just look at the x value because the domain is the x value. So x is greater than or equal to -4. Okay, it goes from -4 on to the right. My range, let me change colors here, is going to be from here down from our y values, right? Because this graph goes down forever. So this is going to go from this point down. And so I look at this number. What's the y value? It's 4. So it's below 4. So y is less than or equal to 4. Okay. So you will be asked to state domain and range on some problems on the test. That's 16. Next one I'm going to do with you is number 20 here. Okay, identify the horizontal and vertical asymptotes, the locator point, and domain and range of each function, then sketch the graph. Okay, so let me erase some of this writing here so that I can change colors first of all. Let's see, number 20, I'm gonna write up here, domain, range, locator point. Okay, so my equation is y equals -1 over x plus 3. Okay, if I remember it from my parent graph toolkit, if you don't remember, you could take a peek at it, but I know that these generally have a branch like here, and we have asymptotes, and it's super important you draw the asymptotes in first. But since there's a negative out in front, that's gonna flip this around. So my branches are actually gonna be here and here, right? Because this gets flipped over here and this gets flipped over here. So really, my graph is gonna go like this, and you need to have arrows on the end, okay? And then you gotta draw your asymptotes in. But this could be shifted around, right? So we have to, right now the locator point is here, but because of this, we have a shift. The general equation is y equals a, or, actually, let me erase that. It's a over x minus h plus k. That's the general equation. So my a value is -1, basically, -1, that tells me it's a flip. And then my h value is -3. There is no k value, so it's like 0. Okay, so what is my hk? I take the opposite of this. The opposite of 3 is -3. And then the 0, there's nothing at the end, so k is 0. And we're going to flip it. So if I do a sketch of my graph, sorry, my line's pretty terrible there. Do I have a line tool? Yeah, I do have a line tool. That's okay. So I'm going to go to 1 to -3. That is, so this locator point has moved from 0, 0. It's been shifted to the left 3. So now you need to draw your asymptotes in. Super important. You draw your asymptotes. If you don't have your asymptotes, well, your graph's maybe not going to be accurate. Okay, and you have to name the asymptotes too. So I know this branch is going to be over here. So at -3, the function is undefined. So maybe I want to plug in -2, -1, 0 to find, normally the branch is over here, but now the branch is going to be down here. So if I plug in -2 into this function, okay, so let me find a place to do that. F of -2. And here I get -1 over -2 plus 3 plus 0. I don't care about the plus 0. So we do this part first, right? So this is 1, the denominator is 1 over 1, and then there's this negative out in front. So I get -1. So that's the point, -2, -1. Right here is my first point, okay? And then when I plug in, let's plug in -1 into the function to find another point. So this is the work I'm talking about. When you do a sketch, you should have some work in it. So when I plug in -1 into here, I get -1 over -1 plus 3, like that. I evaluate the denominator first. So I get -1 over 2. -1 plus 3 is 2, so I get -1/2. Oh, so -1/2 is like this. Okay, and I could plug in 0 into this. Let's see, if I plug in 0, I'm going to get 1/3, right? So you can see my branch is going like this, and it's going to go right up against the asymptote, and the other branch is going to go this way. Okay, and then when I plug in this point, -3, -4, you end up getting 1, 2, I believe. Yes, I'm sorry, 1 right here. I think, yeah, 1. And then you get like 1/2 over here and 1/3 over here. So it mirrors, this side mirrors like that side. And then it comes down like this if you were to plug in more points. And you can certainly plug in more points. I did this earlier and got that graph. Okay, so your graph has 2 branches on this side. To see which side it is on, plug in some points to the right of the asymptote and to the left of the asymptote. And then it's going to tell you to name the asymptotes, right? So the asymptotes are the x-axis. Okay, well, don't write x-axis. The equation for the x-axis is y equals 0. So that's one of your asymptotes. Okay, and this is a vertical line. Remember when we did lines of symmetry for quadratics? Vertical lines are x equals, And this is x equals -3, right? Because it's going through -3. Here's the y-axis, and it's going 3 to the left, which is consistent with this. Okay, basically you could set this equal to 0, the denominator equal to 0, and solve it, and that would give you your one of your axis of symmetries, your asymptotes. Okay, so y equals 0, x equals negative. These are the values where the function is undefined. That's why we have asymptotes. Okay, it's where the function is undefined. There's no value. If I plug in 3 into here, I'm going to get. If I plug in -3, I'm going to get -1 over, and then it's going to be -1 over 0. So that's undefined. That's why you have an asymptote, because when you plug in that number, this -3 is going to make it 0 in the denominator. Also, when y equals 0, it's going to be undefined also. Okay, so domain and range. The domain of this is all real numbers. It goes forever left and right, except -3 is all reals except -3. And you can see that through the asymptote. And then the range is going to be all reals except the other asymptote, 0, right? And I could put all reals like this, except y equals 0. Okay, so that's how you state your domain and range. It's all the numbers except where your asymptotes go, essentially. Okay, so that is number 20. Then we're going to move on to either 22 or 25. Let me clear all this work out. 22, next one. 22, then 25. Okay, get my pen back. 22. Graph this equation. It's an absolute value equation, right? We know the absolute value equations are V's. They're like parabolas, except they're lines and they have slopes. So my y equals a times x minus h plus k. So my h is going to be my hk. It's going to be the opposite of what's inside here. Opposite of +2 is -2. My k is going to be the outside number here, -2. So my vertex, this vertex right here is going to be -2, -2, right? So we're supposed to graph this. So -2, -2 is in the third quadrant. Boom. Boom. I should have put graphs, axes on here. -2, -2 is right here. So that's where my vertex is. Now, how narrow do I make this? How wide do I make this? That's what we need to determine right here. Well, that comes from your a value, right? You could make a table, and sure, go ahead and make a table if you're not sure, but we don't need to, because the a value is your slope. My a value is 2 because it's out in front, right? A equals 2. Well, that's your slope. 2 over 1 is your y over your x, or your delta y over your delta x from math 2, right? So I just need to go up 2 over 1, up 2 over 1 both directions. Keep going, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and I have a nice graph there. Okay, and you definitely want to label the vertex, okay? Whenever you do graphs, label the vertex with a point, with a coordinate, okay, for your work. And beautiful, that's a beautiful graph. All right, so line of symmetry, is there a line of symmetry? Absolutely. Okay, it's symmetrical, so we're going to draw a line like that. Okay, all right. What is that line of symmetry? It's whatever the x coordinate is, that's what it's equal to. X equals -2 because it's a vertical line. That's how you do the line of symmetry for line of symmetry is for a parabola, just x equals whatever it goes through. Okay, I could do a table, but what for? You know, this would be -2, -2. I'd put like -1, 0, -3, -4. I maybe flip that around, and then you would get your values. Plug it in. All right, so that is how you do absolute value equations. Cubic. Next one we're going to do is this cubic equation here. Write the exact equation for the listed function that has a locator point of -3, -2. So that's your h, that's your k. And passes through the point 2, 6. So that's your x, that's your y. Okay, this should look familiar because we just did a problem like this with the quadratic, but how do you do it for a cubic? Well, for a cubic, you just use the cubic equation found on your parent graph. Y equals A times X minus H cubed, that's the difference, plus K, right? So it's cubed instead of squared. Right.
So what does that
Drink some
mean?
water.
Sorry.
So I'm going to plug in everything, X, Y, and K. So I'm going to start with Y. My Y value, you know, go ahead and write down X. Your XY is the point on the graph. So 2, 6 is a point on the graph. And then your HK is what they tell you, the locator point, -3, 2. So I'm going to start with Y, which is 6. So 6 equals the A value, we don't know. That's what we're solving for. The X value is 2. 2 minus, I'm sorry, that's supposed to be a 2. I wrote X. 2 minus, my H value is -3. So -3 squared. You see how that 2 negatives, one from the equation and one because this was negative. Well, that's going to turn into positive. And I keep writing squared. I did that on my, it should be cubed. I did that on my work earlier today. So I'm going to change that to cubed. Cubed. And then plus K. K value is 2, plus 2. Okay, now we do order of operations. Well, you got to do parentheses and exponents first. So 2 plus 3 is 5 cubed times A. Do that first, and you do not add the 2 to the 5 cubed, okay? That does not get added. So you do this together. 5 times 5 times 5 is 125A plus 2 equals 6, okay? Then I'm going to minus 2 from both sides. Minus 2, minus 2. 6 minus 2 is going to give me 4 is equal to 125A. And the last step is going to divide by 125, divide by 125. So my A value, the number in front of the function, is this really small fraction. And you kind of know when you did it right because they tend to be perfect squares and perfect cubes. 4 is a perfect square. 125 is a perfect cube, and this is a cubic. So I found the A value. So now I'm going to take that A value and plug it back into here and plug in the H and a K. That's the equation of the cubic that passes through these 2 points. Okay, so let's plug it back in. Y equals 4 over 125 times X minus, I don't know, it's plus 3 cubed. Make sure that's a cubed, and plus 2. I kind of look at this part right here and, you know, that it's pretty much the same right there. So plus 3 cubed plus 2. That's the equation. If I were to type this into Desmos, I could graph it and it would show me that, oh, this is the vertex. Well, you know, this is a this graph. A cubic looks like this. The locator point is in the middle. So my locator is -3, 2. -3, 2. I'm going to give you the answers next class period, and this answer on the answer sheet is wrong for some reason. I think we changed the directions and we didn't change the answers. So when you get C25, 26, and 27, the answers on the answer sheet are wrong, but everything else should be correct. All right. So that is 25. You've got 1 or 2 more to go, and then we're going to wrap it up for today. So clear all these. Go to the next frame. Okay, 29 and 30 I'm going to do with you, last 2. 29 here. Okay, so identify the center and radius of a circle. Oh, this is a circle. How did we know it's a circle? Because x squared and y are squared. They're both squared, so this is going to be a circle. And it tells us, but if they didn't tell us, if there's an x squared and a y squared in the problem, it's going to be a circle centered somewhere other than 0, 0, probably. Okay, so we want to find the radius and the center, then sketch. This is the first time we're doing this, okay? So, and you're going to see this again. So it's completing the square. So it's not the first time you've completed the square. It's just the first time that we're doing it for a circle. Okay, so I wanted to erase this. All right, so let's what we want to do is group the x's and the y's together. Okay, so here's an x squared and there's a 4x. So I'm going to group those together. Okay, so I'm going to go x squared plus 4x. And then I'm going to need to add some number because my goal is to get an x squared in here. I need to complete the square, okay? Because see, this is sloppy. You know, the equation of a circle looks like this. If you look at your parent graph toolkit, x minus h squared plus y minus k squared equals r squared. This equation looks nothing like that, right? So we're going to get it to look like this by completing the square. This is why we tell you to complete the square with quadratics, even though everybody wants to use a quadratic formula. Well, you can't use a quadratic formula like this. You have to complete the square. Okay, and now we're going to put our y's together. So I have a y squared and a 4y. So plus y squared plus 4y plus some value that we're going to use to complete this square, right? I'm going to use this to make my y's. I'm going to use this to make my x's, group them together. Now this 4 is in the way. You can see there's a 6 here. This is what I'm going to move out of the way. So I'm going to move this 4 to the other side, equals -4. Okay, we don't want that 4. We want to move it to the other side, and we want to find our c values that complete the square. So let's see. If I take half, so my middle number is 4, and that's 2 and 2 split up. So if I multiply 2 times 2, I get 4. So 2 plus 2 is 4, and 2 times 2 is 4. So I need to put a 4 here. And since this is 4, I'm also going to add 4 here to complete this square, right? And because it's the same triangle diamond thing. So since I added 4 and 4 here, I need to add a 4 here, and I need to add a 4 here, right? That and that, those two, this one and this one get added here. Well, -4 plus 4, girls, -4 plus 4 is 0 plus 4. And this is going to be x plus 2 squared, right? If I rewrite this as a perfect square like this, it's x plus 2 squared. And this is y plus 2 squared, right? If I use the diamonds, that makes it y plus 2 squared equals 4. This is now in standard form of a circle. It's in this form. So this tells me, hey, the center, here's my h, here's the opposite of h, here's the opposite of k right here and here. So -2, -2 is the center. And the radius, this is the radius squared, right? Radius squared is 4. So radius squared is 4. So I need to square root both sides. So the radius is 2. Okay. So the way that you find the center is you got to change this to standard form by completing the square twice, which is not hard. They're just 2 separate problems. And this one ended up being the same because both of these were 4s. These are going to be different because I have a 6 and a 2. So you're going to do 2 different completing the squares, but it's not hard. You're going to move the 6 out of the way over here. Okay, and our radius is the square root of 4, which is 2. Okay, and then the last one, this is kind of a new problem too that we need to do. Number 30 is use the information provided to write the equation of the circle. So just like the 2 other problems we did, they're telling us the center, which is the h and the k. So what is your hk? It's 12, 3. What's a point on the circle? That's a point, right? An x, a y, 7, 6, all right? So if I were to graph this just to give you an idea of what's going on here, let's pretend 12 is over here and 3 is over here, right? It's somewhere around there. And then 7, 6 is like somewhere around here, and 6 is twice as high as this one, so around there. So this is a point on the circle. This is the center of the circle. So my circle looks something like this, right? Center at 7, 6. Okay, I'm sorry, 12, 3, that's 12, 3. This is 7, 6 right here. So we want to find the equation of the circle. We have a radius right here, right? And hey, can we find the distance of that? Can we use a distance formula? Well, the equation of the circle is like the distance formula. So hopefully you know the equation of the circle by heart. If you don't, you look at your parent graph toolkit. X minus h squared plus y minus k squared equals r squared. Okay, So we know h, we know k, we know x, we know y. So what are we solving for? R. That's the one thing we don't know. So we're just plugging all these in to solve for R. Okay, we don't have an A value for this. We have an R. So start with the X value. My X value, sorry, I'm going this way. My X is 7. So 7 minus my H value is 12 squared. Okay, 7 minus 12 squared. This is going to feel a lot like the Pythagorean theorem, because basically it is like the Pythagorean theorem. Plus my Y value, let's see, Y is 6. My K value is 3. So 6 minus 3 squared, Pythagorean theorem. See, that's basically the Pythagorean theorem right here. A squared plus B squared equals C squared, because basically we've got a Pythagorean theorem. Here's your A, B, C, but in this case, C is our radius. And this is actually our X, our Y. It's our like X squared plus Y squared equals R squared. Okay, so 7 minus 12 gives us negative 5 squared. Negative is going to go away when we square it. 6 minus 3 is going to give us 3 squared equals R squared. So this is total Pythagorean theorem. Negative 5 squared is 25. 3 squared is 9 equals R squared. We go ahead and add these together. 25 plus 9 makes 34 equals R squared. So the radius is the square root of 34. But actually, we're going to use R squared. We're not going to use the radius, okay? Because our equation is right here. Let me change colors. This is our equation of a circle, right? So we're going to plug in our H, our K, and our R squared. And so R squared is 34, not the square root of 34. So if I use this equation, I'm going to get X. What's my H? My H is 12. X minus 12 squared plus Y minus K. My K is 3 minus 3 squared. Don't forget to square both the X's and the Y's when you do circles. Equals 34. 34. Okay? X minus 12 squared plus Y minus 3 squared equals 34 for your equation. So that is how you find the equation of a circle given a point on the circle and the center of the circle. You're going to have to do that on the next test. Okay, so here's one for you to practice, 31. Okay, so you get to practice 31 to make sure you can do that. All right, guys, if there's something I gotta stop recording here.